Hello, my name is Manuel Rivera. I'm a graduate student from the University at Texas Rio Grande Valley. This is question 2 at Calculus 1 from Spring 2016 from CU Boulder. So now we're going to be discussing problem B, which states the following. Is f of x equal to e raised to the x plus 1 when x is less than 0 and logarithm base 2 x plus 1 plus 2 hyperbolic cosine of x when x is greater than or equal to 0. Is that function continuous at x equals 0? Use the limit to answer this question, right? So here we're going to be talking about, and we're going to be taking the limit from each side of it. So let's look at the first limit that we're going to be discussing. So we're going to be talking about the following limit. So we're going to be looking at e raised to the x plus 1. So we're going to be looking at that part of the function first. So we want to take the limit from the left side. So x is approaching 0, but from the left side. Why? Because x here has to be less than 0. So we're going to write e raised to the x plus 1. And by taking the limit, we can see that that's going to approach e raised to the 0 and the plus 1. And e raised to the 0 equals 1. Therefore, it's going to be 1 plus 1, which is equal to 2. So that will be what that part of the function, when it's less than 0, is approaching 2. It's approaching 2. Now let's look at the other function, but from the right side. So let's take the limit as x approaches 0, but now from the right side. Of what? Of the function, which is equal log, and we have a base 2 of x plus 1 plus 2 times the hyperbolic of cosine of x. Right. So if we look at this function, we're gonna see that by inputting x as 0, we're gonna see that we obtain the following. So we're gonna have the logarithm of base 2 still, and 0 plus 1, that would be 1. Then plus 2 times the hyperbolic cosine of 0. Let me just make this clear. So the cosine or the hyperbolic cosine at 0. So if we see the logarithm base 2 of 1, we can write that as, by our logarithm properties, we can write that as logarithm of 1 divided by logarithm of 2. And the reason we want to do that is because we want to look at logarithm of 1. And logarithm of 1 equals 0. Therefore, that section, 0 divided by the logarithm of 2, that will be 0. So, if we look at the hyperbolic cosine of 0, that's going to be 1. So we're going to have 2 times 1. Therefore, 0 plus 2 will equal 2. Let me write that now. So 0 plus 2 will equal just 2. And we can see clearly that those two functions approach the same y value. Therefore, the function is continuous at x equals 0. So that is the way to solve that problem. Thank you for listening.